To the washing machine question then. It tells us in a washing machine, clothes are placed inside a metal drum with small holes in it. When the wet clothes are spun, the drum rotates at high speed and water escapes through the holes. The drum has a radius of 0.220 meters. That's labelled here, not terribly well, but that's where it is, and rotates at 800 revolutions per minute. Show that the speed of the rim of the drum is approximately 18 meters per second. So we're looking for a connection between the rotation rate and the linear speed of the drum, the rim of the drum. So that clearly is V equals R omega. And omega then, well, that is the angular speed. So that's going to be 2 pi times the number of revolutions per second. So there's 0.220 meters is R times 2 pi divided by, times 800 revolutions per minute divided by 60, which is 800 revolutions divided by 60 per second. And that gives us V equal to 18.4 meters per second, which to 2 sig figs is 18 meters per second. To 2 sig figs. So there's the first part done for 3 marks. So there's a mark's worth there for you. Substituting in here is another mark, and then your 18 gives you your third. I have already drawn on the answer to later on drawing in arrows for A and B because it was very difficult to do on this diagram with Word, so I'll come back to that in a moment. So estimate the magnitude of the acceleration of this piece of clothing. Well, we have some options here. We could use V squared over R. We could use R omega squared. It's your choice what you want to do. But that, if you stick in the values 0.220 and the 800 divided by 60 all squared, that will give you 1.54 times 10 to the 3 meters per second squared. And you might say 1,540 meters per second squared, that's a lot. Well, yes, washing machines do spin very quickly. 800 RPM is not particularly quickly if you know your washing machine, but they do spin quickly, and as a consequence of that, the acceleration is tremendous, which is why it's dangerous to put small animals in washing machines, for example. So that is a realistic figure for the acceleration at the rim of a washing machine. So label arrow A and B. So add an arrow to the diagram opposite to show the direction of this acceleration. Well, that is towards the center of the drum. My arrow, I couldn't place it perfectly. It should go from P really into the center of the drum. And then it says a drop of water becomes detached from the clothing at point P, which is next to one of the holes in the drum. Draw an arrow on the diagram opposite to show the path which the drop of water now follows. Label it B. So there's A. I should have labelled it A, but again, that was difficult on this diagram. This is B, and If you have any doubt about this, what's happening here is that at the point where the drop of water loses adhesion to the drum, it loses the centripetal force, it loses the centripetal acceleration, and so by Newton's first law, it will continue doing what it was doing before, which is traveling along this tangent.